myself. All right. Today's the 4th.
That good? Okay. Hey. Tuesday.
It is Tuesday. Nice work there, Ryan.
Thank you.
Um,
No.
I just wanted to take that for a spin. I didn't like it.
I agree. You didn't like it?
Nah, it didn't feel right. Um, yeah, let's do this. I have 4 examples. All right. So I just wanted to get to this. I know that some of you are going to finish the assignment. I think it was assignment 16, maybe something like that. And you're going to get that done. So then when you're done, you're going to hop into Delta Math. I couldn't get a worksheet to generate with this concept, so I just went into Delta and it had it. So I stole it and threw up a 20 problem assignment for you. So what's the matter? Is that too many? Son of a gun?
Pencil.
Oh.
Take lead.
Figured let's just knock this out. And then I can give you the rest of the hour to work, and then tomorrow will probably be a good practice quiz day. I'm thinking this little baby unit, I've decided I am going to just quiz you on equations, and we'll get that done, wrapped up, put a cute little bow on it, and then we can move into the hard stuff, the inequalities. Okay, so quiz maybe Thursday. We'll see. I don't know how much time. Let's see where you're at. Let's touch base tomorrow and kind of see what the vibe is. I don't want to rush it. I don't want to cause like retakes and stuff. So anyhow, yeah, so this is what we're going to work on today is absolute value equations when it's not just a numerical value on the right. But it's okay because what we understand, like our process is still going to apply. No worries. What does your instinct tell you you ought to do first? Subtracting 8 is just a perfect answer because as we know from yesterday, our goal is to get the absolute value by itself. So if I take away 8 from both sides, I'm left with the absolute value of x minus 4 equals 3x minus 8. Don't do something rookie and try to like combine on like terms or something like that. Those have to stay separated. It's at this point that you're going to do the split. You are always going to do the split. And the reason we are always going to do the split is because we can't pass judgment. We don't know what X is. Like if someone told me right now, by the way, like psst, X is -2, then I could say no solution. Like you understand that? Because I wouldn't be able to equal to -14. But at this point, X varying as a variable means I have no idea what value of X I'm going to discover. So this isn't a matter of writing no solution. There may be a time at the end of the problem here in about 2 minutes where you write no solution, depending on the outcome, but we'll cross that bridge when we get there. For now, what I would write down if I were you is with these ones with the variables on the right, always do the split. So we're going to split over here and we're going to split over here. And we're going to embrace our fundamental understanding of absolute values. And that is that the stuff inside the absolute value, x minus 4, could possibly equal exactly what it says on the other side, 3x minus 8. Right? It's just yesterday, a little bit buffed up on the difficulty scale. Like as far as some of you with anxiety might go, oh my God, this got really hard. It's not that bad. And then the green one is going to say, hey, maybe the stuff inside the absolute value equals the opposite of what's on the other side. Just like we did yesterday, like equals 10 equals -10, equals 5 equals -5. What is the opposite of that green egg? Good job. Good fundamentals. -3x plus 8. If you take the opposite of a binomial, both terms get opposited. And then at this point, you just go back and flex. So I'm having a hard time with you over there, J-Lo. You got a concussion protocol or something? So we're just going to solve this equation, the purple one and the green one. What would you do on the purple one? What else?
Add 4.
Sure, I'll take it. You could honestly say subtract x, add 4, subtract 3x, add 8. If this were algebra 1, I'd bully you around a little bit more as far as my preferences as to what I think you should do. But if you want to add 4, I am down. Right? It's a free-for-all. And that's one of the things we learned about classic three-step equations like this is as long as you end up with your objective, done. Variables on one side, numbers on the other. Then at the end of the day, no one really cares how you get there. So I'm left with my x over here equal to 3x minus 4 now, because I added the 4 to the negative 8, like terms. At this point, I would no longer accept any one of 4 answers. There is only one answer. What do we have to do now? See, we're a little rusty on our basic math. You have to subtract 3x at this point. Don't forget from algebra that your core objective is to separate, to say x's go one way, numbers go the other. And again, no one really cares which side you pick for which. You do you, but the x's now have to officially go to the other side because the constant numbers have taken over the east side. So we're going to take the 3x away like this. And then we're going to be left now with negative 2 x's being equal to negative 4. So what does x equal? 2. I'm not going to box that up yet because we have to verify these answers. This is a new twist today, is that just the fact that we get an answer isn't enough for us to say, carry on, bless you. So don't box it yet because we're going to go back and vet it after we're done finding the other one. So let's solve the green equation. And again, I would take any one of 4 answers. What do you want to do to the green equation? That would be my preference, would be to add the 3x. If you remember this about me in Algebra 1, I was kind of a bully when it came to controlling your variables first. So I spend a lot of weeks in Algebra 1 talking to kids about control your x, control your x. You should put the x on the side that you like. Or if you always want x to be positive, put it on the side where that will be true. I'm a big, big proponent of controlling your variables first. So I love the answer of let's add 3x. I mean, it accomplishes 2 really good things. Not only does it put the x on the left where most of us like it, it also conveniently makes the x positive, which is a bonus. So we end up with 4 x's now. Minus 4 equals 8. And now you're locked. Right. In the original step, you got 4 options. Now you're locked. You have 1. What is it? Adding 4 gives you 4x equals 8 plus 4. And then divide by 4, which gives you x equals 3. So what we're going to do now is we're going to check these answers to see if they could possibly be legitimate answers. I don't know. I don't think you've had a ton of experience with this, but every once in a while, you're going to get answers. You should write this word down. You're going to get answers that are what we call extraneous. And it's a funky little word, but basically in math, at all different levels, you're going to find sometimes that you do math. You'll see it several more times this year, by the way. You do math and you get an answer, and then you realize, I didn't do anything wrong, but this answer couldn't be a right answer. It's weird. So we call those extraneous solutions. So that's what we're going to do right now is we're going to test them to see do they work or are they extraneous? Let's test 2 first, the purple one. We claim x could equal 2. If we go back to the original problem, which is way up here at the top of the board, if I put 2 where the yellow arrow is pointing and that yellow arrow is pointing, what right away do you see? Maybe you know what? That's not the right question. Let me go to this one and ask my question. That was dumb to ask it there. Let's test this one and this one. Those little tiny yellow spots up at the top. You see them? Let's change those into 2. Over here on the left, what's 2 minus 4? Negative 2. So we have the absolute value of negative 2. I got no problems with that. You can evaluate anything inside an absolute value. Negative 2, 2, 5, 1.6, 0. Like it doesn't matter. But my concern lies on the right-hand side. If you put a 2 in there, what is 3 times 2? What is 6 minus 8? Can the absolute value of negative 2 equal negative 2? Therefore, that solution is not valid. And we would take that and we would give it a light cross out. Don't destroy it so that your teacher can't see it. Just give it a cross out to acknowledge that I tested it. It's no bueno. It can't work. Let's go back up to the same sweet spot and let's test 3. And again, I'll stay on this one. I like this one because it's a little bit more cleaned up, ready to go. If I put 3 in on the left, I get the absolute value of 3 minus 4, which is -1. If you put 3 in over here, what's 3 times 3? 9 minus 8. Does the absolute value of -1 equal 1? Therefore, I keep this solution. And I'm a big proponent of doing something with your answers. You should not at this point now leave answers just buck naked out there. You should do one of two things. You should cross it off to show me that you've tested it and it doesn't work, or you should box it up to show me that you've tested it and it does work. So this particular equation, even though we split it, only has one solution. Let's go again. This next one shouldn't take quite as long. This one's going to be the absolute value of 4x minus 6. And it's just going to equal 2x. No prep work necessary because the absolute value is already by itself. So we are immediately just going to go into split mode. So we're going to go 1, 2. Just create 2 equations right off the bat. What is our first equation going to say? Mm-hmm. Basically, it's a copy of the original with the absolute value bars not there. That's really important that they're not there. And it can just equal what you see, 2x. What's the green one going to say? So be more specific. So we keep the cream filling stuff the same, right? Never modify the absolute value contents, but then we just take the opposite of the right-hand side. And we're back again just to fundamental basic algebra at this point. I wouldn't feel at this point like you have options with either of these equations because there's not all 4 terms. I feel at this point like the -6 has pretty much put his foot down and said, this is my side. So who has to go? The 4x needs to go, right? We don't ever lose sight of that objective, and that is to separate. X is one way, number is the other way. So we're left with -6 being equal to what? -2x, therefore x is equal to +3. Don't box it, don't cross it, just let it sit there. Let's go test or not test, but let's go solve the green one. Green one, the same mentality. Don't you dare stockpile all your stuff on one side. That's how we treat quadratics and other equations when we're looking for zeros. Solve it. So 4x has to, again, go. If we subtract the 4x across, we're left now with -6 being equal to -6x. What does x equal? Good. Now we test. Let's test 3 first. If I put 3, again, where the little yellow arrows are, on the left-hand side, 4 times 3 is 12. 12 minus 6 is 6. I have the absolute value of 6 being equal to something. On the right-hand side, what's 2 times 3? That one is good. I can box that one up. All right, let's go test greenie. If you put in 1, where the little yellow arrows are pointing, you get 4 times 1 is 4. 4 minus 6 is -2. So we have the absolute value of -2 being equal to 2 times 1. True or false? Very true. So we box them both. Okay, got the idea? Couple more. The absolute value of 2x minus 1 minus 7 equals x. What do we do first? Get that 7 out of there. Right. Get that absolute value alone. That's going to get you through the entire next 4 weeks of my class. It's just get the absolute value by itself. I mean, it's not going to get you all the way through, but you can't get through without it. So we're going to have the absolute value of 2x minus 1 being equal to the quantity x plus 7, and it's go time. So we're going to split. What's one of my equations going to say? The purple one, I guess.
+1 equals x plus 7.
2x minus 1 equals x plus 7. So one of your equations is, again, essentially a carbon copy, but the absolute value bars have to come off. What's the other equation going to say? 2x minus 1 equals what?
Negative X.
Negative x minus 7. So when you change the sign, you change the sign of all parts. That's how equations work. It's essentially just distribution of a negative. Any questions about the split? And now we solve. I feel like in a class of this level, I should be within my rights to just say x equals 8. I don't know that that should be the kind of thing at this point, November of Algebra 2, where I should have to justify everything like that. Hey, move the x, move the 1, get it all done at once. This one I am going to show a little bit more work just because there's a couple of a little bit more taxing perhaps, but I am going to jump to 3x equals negative 6. Do you understand the two things that I did? Because now would be a good time to ask. Okay. We all agree I added the x to get 3 x's. I added the 1 to get negative 6. Therefore, x must equal, there you go. Again, don't box them. We're not sure yet. But the good testing spot is not, again, going to be the original problem. You kind of saw me booth that in the first example. I would test in the more ready to test spot. The right before the split spot is the sweet spot. So let's take like 8. And again, we're going up in the yellow arrows there. What's 2 times 8? 16 minus 1 is 15. So we have the absolute value of 15 equal to what's 8 plus 7? I like that answer. Okay. Let's test negative 2. What is 2 times negative 2? Negative 4 minus 1. So we have the absolute value of negative 5 being equal to negative 2 plus 7 is 5. So here's an example of one where we would box them both. Would anyone in all their genius like to make a guess, a conjecture as to what example 4 will entail? Nailed it. So let's knock this out and make it official, and then we'll get some work time here. So we're going to do the absolute value of 4x plus 1. And I'm just going to skip a step here. There was a plus 1 here. I'm just going to move it to the other side. You don't need to keep dealing with that. So I'm just jumping right to the go time step, and it's time to do a splitty. J-Lo, what do you think about one of my equations over there? Okay, good. Perfect. So we're going to have 4x plus 1 equals 3x minus 1. And again, I want to stress to you that the original thing up in white does not count as one of your equations. All right. It is the thing that we don't mess with. It spawns the ones we mess with, right? And then the green one is going to be what? Nice job. Switch the 3x to negative, switch the minus 1 to plus 1, and now we just go algebra 1 mode on the math gods here. So let's talk purple guy first. What does x equal? Negative 2, solid. And on the green one, what does x equal? Good. Good math. I'm not even going to start doing work that fast in Algebra 1 until months from now. But with you guys, I feel like I can get the X's on one side and get the numbers and do all that. We're pretty capable of that, right? So there are our two candidates, not solutions, but candidates. Let's go test them and see if they work. Let's start with negative 2. Really, honestly, I don't even give a rip what's inside. I have enough information right now that if I put negative 2 right there, what's 3 times negative 2? Negative 6 minus 1. You're never going to get the absolute value of anything to equal negative 7. Therefore, this one is going to be no good. No bueno. Right? Again, I don't care what's in the absolute value because it's just never going to work at this point. And if I put in 0, the same logic kicks in. I just worry about this one over here. What's 3 times 0? And 0 minus 1 ain't going to happen. The absolute value, you could spend 1,000,000 human lifetimes trying to find that number whose absolute value is negative 1. It ain't going to happen. So therefore, this one has no solution. So I wanted that lesson to include all 3 flavors. I want you to understand that you don't make early decisions about do I or don't I split. You always split, you always solve, you always test. And sometimes you get two that work, sometimes you get one, sometimes you get none. So this will be on the Delta Math after you have finished the paper worksheet. Questions? I'm going to keep the recording alive, paused, so that if you say on the paper worksheet, can we go over this or this or this, then I can throw it into the recording, kind of a one-stop shop. All right, go forth and math, young grasshoppers.
Really